This is Dr. Eddie Morgan with Clovis East High School. Welcome to Homework Help for Worksheet 1.4. Just a reminder, each of the problems in this homework help are very similar to the problems on your homework. If you have a problem with a homework problem, look for the corresponding problem here. Watch how we work it here, and you should be able to figure out how to work your homework problem. So let's get started. Problem 1 says solve each equation for m. Then find the value of m for each value of n. So we're going to start with this equation here. And the first step we want to do, I'm just going to rewrite the equation. And we want to solve for m. So to get m by itself, we need to get rid of this term here. So I'm going to subtract 4n from that side. And whatever I do to one side, I have to do to the other. And I use the subtraction property of equality. So 4n minus 4n is 0. That leaves me my m equals 6 minus 4n. That's my solution. That's the first part. I've solved the equation for m. Now they want to know, well, what does m equal when n equals these three numbers? So we just plug them in. So first of all, when m is 2, when n equals minus 2, m is going to equal 6 minus 4 times minus 2. All right. So m equals 6 times minus 4 times minus 2 is plus 8. And so we end up with m equals 14. So that's when n is minus 2, then m is 14. Let's try it for the next one. When n is 0, then m equals 6 minus 4. And this time we put in 0 for n. And so m equals 6 minus 4 times 0 is 0. So m equals 6. And when n is 0, m equals 6. And then lastly, when n equals 1, m equals 6 minus 4 times 1. So m equals 6. 4 times 1 is 4. 6 minus 4. So m equals 2. So when n is 1, then m is 2. All right? So that's problem number 1. Similar thing with number 2. Solve for m. So let me write this down here first. Here's my m I'm solving for. So just ignore the fact that n is a variable. Just treat it like any other number. Like a two-step equation, the first thing I'm going to do is subtract 10 from both sides. And so I have minus 4n minus 10. This confuses students sometimes because I'm not combining them, but I can still write it that way, equals 5m. And now undo 5 times m by dividing by 5. And notice here when we divide, I have to divide everything by 5, the whole equation. So I end up with minus 4/5 n minus 2 equals m. So that's kind of a messy equation. Or if I turn it around, m equals minus 4/5 n minus 2. And that then is my equation for m. I just rewrote it for m. So now we have to plug in n and find out what the values of m are. So let's start over here. When n equals minus 1, then m is going to equal, I take my equation here, minus 4/5 times minus 1 minus 2. So m is going to equal minus times the minus is plus, so that's just 4/5 minus 2. Well, if you want to break this down, 2 is 10/5. So I can say 4/5 minus 10/5. I'm just changing that into the same denomination. And so 4/5 minus 2/5 is negative 6/5. So when n is minus 1, then m is minus 6/5. Kind of messy, but not too terrible. When n equals 0, m equals negative 4/5. Write my equation, and then for n, put in the 0, minus 2. And you can see that minus 4 times 0 is 0. So I end up with 0 minus 2, or simply minus 2. So when n is 0, m is minus 2. And then the last one, when n equals 1, m equals, use our formula again, minus 4/5 times 1 this time, minus 2. And you notice this time here, I get m equals simply minus 4/5. And then remember 10, if I write it as tenths, is simply 10/5. So we get minus 4 minus 10, so we end up with minus 14/5. So when n is 1, m equals minus 14/5. Pretty simple. It's just some of you still get fraction brain freeze, and you probably panicked the moment you saw a fraction there. But just stick with it. They're not too bad if you just don't let them get to you. Next question. Here we're going to solve for x, okay? And they want us to show us how to do it. Now, this is interesting because I have an fx and a gx. By the way, if this were example, if this were 2x plus 3x, what would you do? You'd combine terms and you'd say, oh, 2 plus 3 is 5x. Well, that's similar to what we're going to do here. We're going to combine like terms. And I want you to watch this. We don't know what f and g are, but we can it's kind of like the reverse of the distributive property. Here I said 2 plus 3 gave me 5. Notice I could have said 2 plus 3 times x, which gives me 5x. Here we don't know it, so that's what we do. We just put f plus g together times x equals h. Very important you see that, because I can combine terms. It looks kind of funky here, but that's how we get that. And now I have some number f plus g times x. To undo the multiplication, I'm going to divide by f plus g, whatever that is, and do the same on the other side. So this is the division property. Of equality. Now notice f plus g divided by f plus g is 1. So my answer is that x equals h divided by f plus g. Okay? Very important to see that concept there. Notice again here how the fx plus gx became quantity f plus g times x. It's kind of the distributive property in reverse. Okay? In the next one here, first thing we're going to do is get rid of the parentheses. So I'm going to do the distributive property, negative 5 times quantity x plus n. Let's not lose the negative sign here. So I'll write this out a little more than I might normally. I'm going to end up with negative 5 times x plus negative 5 times n equals x. There's my parentheses. So this is going to be negative 5x, negative 5 minus 5n equals x. Now we're solving for x, so we want to get rid of it. We want the x by itself. So in this case, which is less, 1x or minus 5x? Minus 5x is a smaller one, so we're going to undo that. The opposite of subtracting 5x is adding 5x. So this is 0, and I get minus 5n equals 6x. And now we're solving for x, so to undo 6 times x, we divide by 6. And we get minus 5n divided by 6 equals x. Pretty nasty. Let me go up here and notice what rules we used here. This was a distributive property. At this point here, we did the addition property of equality, where we added 4x to both sides. And then here, of course, we used the division property of equality, which says we divided both sides of the equation by the same number. And of course, we can turn that around to make it easier to say x equals minus 5n divided by 6. Lots of times mathematicians will write it this way. They'll just put the negative in front. You can actually put the negative sign in the top, in the bottom, or in front of it. You just can't put it in two places because that would change the sign then. All right? Next problem. Solve for x. All right? Well, I have x minus n over p. Well, how do we get rid of fractions? Remember that? If this were x minus 5 divided by 2, one way you would get rid of it is multiply it by 2 to get rid of that. So that's what we're going to do here. We're going to multiply both sides. Let me write down here multiplication. I'm going to multiply both sides by the p. So I'm going to have p times m on that side equals p times x minus n over p on this side. So here I get pm, and over here p divided by p is 1 equals x minus n. By the way, this could be pm or mp. It doesn't matter. Now I'm solving for x, so I undo the minus n by adding n. And we end up with pm plus n equals x. Or, by the way, this was the addition property of equality. Or I can turn it around and say x equals pm plus n, or I could change the letters and write x equals mp plus n. We don't really have a set way. Sometimes some mathematicians say put them in alphabetical order if you don't know, but this would, either way would be correct. Okay, next problem. All right, we're solving again for x. Notice there's my x. So once again, just like before, how do we get rid of the denominator? Well, we multiply by the common denominator. So what I'm going to do is I'm going to multiply by x plus 3. So what I have here is x minus 5 divided by y plus 3, and I'm going to multiply by the quantity y plus 3. I'm going to put parentheses just so you see I'm multiplying by the whole thing. And over here, I have 6 and I have a y plus 3 too. Okay, this is our multiplication property of equality. Notice I multiply both sides by the same number. Okay. On this side, y plus 3 divided by y plus 3 is 1. That's what we were trying to get rid of. And so I just have my x minus 5. Here we're going to have to do a distributive property. 6 times that. So I have 6 times y plus 6 times 3 plus 18. Now we're almost done here. We have to undo the x minus 5 by adding 5 to both sides. That's 0. So I end up with x equals 6y plus 23. And there's our answer. Next problem, they want us to solve the problem and round at the end to the nearest tenth, if necessary. So Stan's purchasing subflooring for a kitchen he is remodeling. The area of the floor is 224 square feet, and the width of the kitchen is 14 feet. Well, you know that if I have an area, I have a length and I have a width, and the area is the width times the length. All right. In our case, let me just write that out here. Area equals width times length. Let's plug in what we know. We know the area is 224 feet squared. We know the width is 14. And what we don't know is the length. So we have a simple equation to solve. How do I undo 14 times L? I divide by 14. Got to do it to both sides, though. And so get out my handy calculator. And I find out that this is 16 equals L. So, or L equals 16. And the answer is L equals 16 feet. the length must be 16. Notice that when you multiply feet, 14 feet times 16 feet, you get 224, but notice feet times feet is what gives you feet squared, or square feet. Problem number 8 gives us the way to find the average number of points per game a player scores. Notice the average, this is the average points per game. You take the total points they score all season and divide it by the number of games. Now in our case, they tell us that she scored a total of 240. Well, that's her total points. It goes right there. But she averages 16. Well, the average goes there. So what we're looking for is the number of games. So we're going to take this formula and plug in what we know and then find the number of games. So her average was 16, and that equaled the total number of points, 240, divided by the number of games she played. I'm going to let that be x. So let's find x. Well, first thing, this is a little tricky because we got the x in the bottom. We don't like to get that in the bottom, so let's get the x out of the bottom by multiplying both sides by x. Okay. So I get 16x, and then x divided by x is 1 equals 240. Now, how do I undo 16 times x? I divide by 16. Both sides again. Take out my handy calculator, 240 divided by 16. And that tells me that she played in 15 games. So she scored 240 points in 15 games, which averages out to be 16 points per game. Solve each equation for the given variable. So we want to solve this one for L. Notice you could get this equation, they have you solve it for W. So let's start off here. I'm going to put down the equation first. And this is just our given equation. You'll sometimes see that in a proof. And I want to solve for L. Okay? So, to get L by itself, we need to get rid of the 2W and the 2. So let's start just like a two-step equation by getting rid of the 2W. So I'm going to subtract 2W from both sides. This is just like working a regular one. The only difference is students sometimes get confused because they're subtracting. They're used to numbers and not letters. Notice by doing this, this goes away. And of course, this is the subtraction property of equality. So we get P minus 2W equals 2L. Now our next step is to undo the 2 times L. The opposite of multiplying by 2 is dividing by 2. And remember, when we come over here, everything has to be divided by 2. Okay? So this is the multiplication property of equality. So here I have P over 2 minus 2 divided by 2 is 1 minus W equals L. Or I can reverse these and simply write L equals the perimeter divided by 2 minus W. And there's my solution. In this case, they want us to solve the circumference for D. So let's write our equation down first. C equals pi times D. So that's the given equation. I want to solve for D. How do you undo D times pi? Well, we divide by pi. That's the division property of equality. Pi divided by pi is 1. And so we have C divided by pi equals D, or we can simply, by the reflective properties, flip that around and say D equals the circumference divided by pi. And there's our answer. Similarly, here's the area of a triangle, and we want to solve for B. So the area equals 1/2 base times height. Notice with the variables, remember you don't have to put the dot. You don't have to put 1/2 times b times h. It's understood that's 1/2 times b times h. That's given. We want to solve for b, so we want to get rid of the b and the h. Well, first thing, how do you get rid of fractions? You multiply by the common denominator. So first thing I'm going to do is I'm going to multiply 2 times a on this side equals 2 times 1/2 bh on this side. That's the multiplication. Property of equality. And so on this side we have 2a. On this side, remember, this is a string of products. 1/2 times b times h. I just have to multiply the whole thing by 2. I don't go 2 times 1/2, 2 times b, 2 times a. 2 times 1/2 is 1, so I'm just left with bh. Now we're solving for b, so how do we undo times h? We divide by h. H divided by h is 1, and this is the division property of equality. And so we have 2a divided by h equals b, or I can turn it around to write it more properly. B equals 2 times the area divided by the height. Okay. This time we solve for b. Notice you could do the same problem. They could ask you to solve for h sometime, and you'd end up with something very similar. Here's our distance traveled. Distance equals rate times time. That's just saying if you're going 20 miles per hour for 3 hours, 20 times 3, you'll go 60 miles. So let's write down our formula. Rate times time, that's the given. And they want us to solve it for the rate. Well, rate is being multiplied by time. So if I want to undo multiply by t, I divide by t. I use the multiplication. Property of equality. T divided by t is 1, so I have d divided by t equals r. Or if we reflect that around, r equals d over t. And there's our answer. So we've taken the distance formula and just changed it for rate. We could have also written it for time. We could write it for either one of those.